Okay. All right. So you can see the screen is tailored just for you alone, for your school, and we go through this together. Um, some had asked me to do organic reactions, but I think someone then said, why don't you do a full paper? But when I get to organic reactions, I'm going to slow down. I'll give you a quick summary, and then we'll use that to answer a question. But we want to touch base on everything, starting from multiple choice. Guys, quickly look at this multiple choice and give me an answer for the two of them. You have 3 minutes for the two. No wasting of time. 3 minutes for the two. Try to reason things out, no guessing. These two are just basic content type of questions. All right, I think we should be done with the two. This is where, if you don't know it by now, you are only going to guess. If by now you cannot think through, so I'm just going to save time. We want to go through 10 questions. So, okay, let's answer this. Number one, the equivalent unit of force. This is how you answer this question when the examiner asks you for the unit of force. Now, we know that force is actually measured in newtons. But once they say the equivalent unit, let's look for the formula for force. What is force? We know that F net equals to what? MA. What is the unit of mass? Kilogram. What is the unit of acceleration? Meters per second what? Squared. Is that there? Yes. Correct option is B. So that is how we treat all of those. We use the formulas. It says the equivalent unit. I hope that makes sense. I hope that really makes sense. That's how we answer that. 1.2. A learner drops two identical cell phones, A and B. All right, great. From the same height. Feel free to let me know wherever you were lost. Cell phone A falls on a concrete floor and its screen breaks. Okay, for A, it breaks. And cell phone B falls on a something clothy, carpet, and its screen does not break. Beautiful. Momentum. Which one of the following combinations is correct for cell phone B? We're looking for B that did not break compared to cell phone A for the same change in momentum. What is this formula saying? This formula is basically talking about F net delta P over delta T. And we know that for the same change in momentum, the net force is inversely proportional to time. We're saying longer time and small force. Because the cell phone screen did not break, the force is kind of small. All right, so the small, why? The time increases. Correct option is C. So if you know how to answer this, first thing is to cancel out options. Net force on B, it cannot be larger because we are told it did not break. So smaller, smaller. And then you go back to the formula. The net force is inversely proportional to the change in momentum. For the force to be small, the time has to be large. 1.3 and 1.4. Quickly. You have yourselves 3 minutes because I see this one requires a bit of calculation. All right, let's say 4. Please don't guess. Make sure you get answers. Don't guess. All right. We are done with our timing. I'm sure you have answers now. All right. Just going to show you how we do this. Two trolleys A and B with masses half M and M respectively are connected by the spring as shown in the diagram below. The trolleys are initially at rest. Ignore all types of friction. When the spring is released, both trolleys have a momentum with a magnitude of p. Take note of that. Trolley B moves with a velocity of v to the right, which makes sense. All right, v to the right. The examiner says, what is the magnitude of the velocity of A? Okay, we know it's going to move to the left, but we don't know the velocity. But the momentum, check. When the spring is released, both trolleys have a moment. Let me show you from the scratch. These objects were connected. So if I say MA plus MB, initial velocity is MA VFA plus MB VFB. Okay, masses don't matter from the beginning because this one is 0. Now we're told that they both have a magnitude of momentum P, but let's do something first. So MA, MB, VFB. What is the mass of A? Okay, let's call A 1 over 2M. So 0. We don't know the final velocity of A, but we are told that the momentum of both of them is P. So I'm going to say P here. Okay, will that work for me? Will that work? Now I need to get my answer in terms of V. All right, let's do this. M, V, because we are told the velocity is V. Lovely. If we are to solve for VFA, what would it be? I can divide both sides by, or let me make it simple for you. If I factor out M, even if I don't factor it out, let's move 1 to the other side. Negative 1 over 2 M VFA equals to MV. Let's look for VFA. M would cancel each other, and we are going to have what? Negative 2V. But we want the magnitude, so the magnitude will be 2V. You're just doing things normally. We're not guessing answers. The answers will come out. So you just do your normal momentum and get your answer. 1.4. An object is thrown vertically upwards. Which one of the following reading regarding the object's acceleration at the highest point of its motion is correct? Oh, lovely. We are looking for acceleration. And because it's a free fall, at every point, even at the maximum height, it is 9.8 meters. Ooh, this one is wrong. D. 9.8 meters per second squared downwards. Let me know if we are on the same page. Are we on the same page? No, wait, guys, there's an error here. It's 2M, 1.3. I'm just seeing something now. It is half M and 2M. Sorry, it is half M and 2M. All right, 2MV. Multiply that by 2, that should actually be 4. I just went up now and I saw that. So that's 4. But you get the whole idea, right? 4V. So it should be D. Because they said the mass of B is 2M. I wrote M. All right, I hope we're good. Lovely. So please, when it comes to questions with calculations, we're not guessing. You're working things out. And please keep an eye on units. For example, 1.4, 9.5 meters per second square downwards, even if it's at the maximum height. All right, 1.5. It's just one question here, 2 minutes, 30 seconds. All right, were you able to get an answer for me here? Were we able to get answers? Remember, if you do it and you're not getting one of these answers, it means that you're cheating. A ball is dropped from rest and reaches a velocity v after it has traveled 3 meters. Let's try to create a little diagram. So it is dropped from rest. Initial velocity is 0. It has traveled 3 meters, and we know that the final velocity is v. That's what we are told. What will the magnitude of the velocity of the ball be if it travels 9 meters? I know maybe some of you are just saying 9 or something, or 6, but I doubt. We're looking for, let's see something here. VI is still 0, 9 meters. Now we don't know the final what? Velocity. Okay, let's see. If we choose down as positive, I can use, I need to have my VF. All right, I need to have my VF. Let's see. We can use VI squared equals to, no, VF squared equals to VI squared. All right, those are the things. VF squared, VI squared plus 2A delta Y. For the 3 meters, what is our VF? V squared. Initial velocity is 0. 2, don't worry about the value of A, we'll deal with it. And this one is 3. So what do we have? V squared would be what? 6A. What is V? Okay, let's leave it as, all right. Let's see. I want to see where we're going. Now, when I come to the 9, using the same formula, VF squared equals to VI squared plus 2A delta Y. I do not know my VF squared, but my VI is still that, 2 multiplied by A, and then my delta Y is 9. So my VF squared is 18A. All right, this is where it gets interesting. I need to write the first one and the second one to look like something that we know. We are looking for what our final velocity. All right, I see something. Now look at this 18A. This 18A can be written as 6A times 3. Why 6A? I want to bring this guy in. What is 6A? 6A is V squared. So the final velocity, therefore, instead of writing 6A, I'm going to bring in, it's 3V squared. Now let's look for the square root of that, of 3V squared. The square root of V squared is V, so we have V root 3. And the correct option is B. So these are dynamics of answering multiple choice questions. I don't know if that made sense. I did the 3 meters and I did the 9 meters. I now try to merge both of them together. They are quite tricky. So when you see something like this, please just remember to do what I did. All right. So I quickly saw that, all right, here I have 18A, but I need to bring this guy in because I see that all my answers are V. So what is V squared? V squared is 6A. So I broke this down and I said 6A times 3. And 6A is V squared. So it's 3V squared. Found the square root, and that is how we get our multiple choice questions. All right, here quickly. I don't think this one should take, this one I'll just give you 1 minute and 30 seconds. You read. Let's make it 45. Read quickly. All right. The velocity versus time graph represents the movement of an object that is initially projected vertically upwards. Ignore the effect of friction. The displacement of the objects after 2t. All right, we're told that this thing moved upwards. And it makes sense. Let me call this point A, point B. Now, they said after 2t. So let's call this point C. It's actually very, very lovely. And the answer is actually 0. Why? You can see what's happening. Object moves up, reaches maximum height, and at t seconds, whatever time it takes to go from the bottom to the top will be the exact time. So you can see t and 2t. So object is back at the original position, and its displacement therefore is 0. Displacement is the position from the starting or reference point. So object is back at where it started from. That's why the displacement is 0. They just want to confuse us with all of these other funny things. Oh, organic chemistry. Here quickly, let's see. 2 questions. 2 minutes. You should be done here. 2:30. 1 minute for each. Read and answer. Were you able to get answers? When it comes to organic chemistry, please draw. Drawing will save you a lot. Look at this one. CH3COO, already I know it's an ester. CH2, 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 CH3 is a condensed formula for which compound? Let's draw. It says CH3, then C, then O. That's my COO, then my CH2, my CH2, and my CH3. To name an ester, what do? You split it up here. That's where you split that thing up. And the alcohol, so this double bond tells me it's the carboxylic side. This is the alcohol side, with the one without the double bond. So it's 3. Propyl. Oh, straight. Propyl ethanoate. Answer is B. So once you identify that, you just automatically pick your answer. So we start with the alcohol side, prop, and it's propyl. The list below has IUPAC names of compounds with 5 carbons, okay? A functional isomer of pentanal. All right, pentanal is an aldehyde. For those of you that I taught, I remember telling you about cake. For those of you that were in my class that day, functional isomers. We said for a function, you need a cake. Aldehydes and ketones, carboxylic acid, and esters. So, pentanal is an aldehyde. It means the functional isomer has to be a ketone. And the ketone is on, which is pentan 3 on, and the correct answer is C. It's just basic content, guys. You need to read and know your content. That's how you're going to survive multiple choice. All right? Another 2 minutes here. Let's see, 2 minutes should be fine. Okay, time for marking. Which molecular formula of an organic compound is similar to the empirical formula of butanoic acid? And to which homologous series does the compound belong? Okay, let's go back again. Which molecular formula of an organic compound is similar to the empirical formula of butanoic acid? First question is, what is butanoic acid? Let's see. Butanoic acid, if you're not sure, you quickly draw. 1, 2, 3, 4. All right. Okay, so it's C4, H, 1, 2, 3, 4, 5, 6, 7, 8. All right, so let's go back and read the question. It says, which molecular formula of an organic compound is similar to the empirical formula? Now, what's the empirical? Grade 11. Empirical formula, let's write this as a ratio. Divide everything by 2. It's C2, H4, O. That's the empirical. This is molecular formula. All right, beautiful. So that's the empirical. Which compound is this? If I were to draw this, it's either an ester, an aldehyde or a ketone. if I draw a ketone? What a lovely question. Do you see that? C2H4O. So I already have my answers. C2H4O, and it's an aldehyde. Lovely. My answer is C. So it could have also been a ketone, but here we only have what? Aldehyde. Do you guys understand the question? Do you understand how I treated the question? Empirical formula of butanoic acid. So please always draw. Diagrams are always the easiest way to go. Which compound has the lowest boiling point? Okay, definitely we should know that the more side chains it has, the lower its boiling point. And the one that has more side chains is actually A. You can see it has 2,2-dimethyl. The chain is shorter and it has more side chains. So it has the lowest boiling point, but the highest vapor pressure. All right, guys, that's your multiple choice. I believe somebody learned something there. Somebody must have learned one or two things. Quickly, let's answer the next one. I'm going to give you time to try, guys. Please. I won't be giving you so much time, so you have to do it very fast. This is 14 marks. I'm going to give you 12 minutes. Try to work as fast as possible. Get the most marks that you can get because of our time. I just don't want to do the questions. All right, there we go. Awesome, guys. Time up. I'm sure you were able to do what you could do, and I'm sure you were able to walk through. Let's walk through this question. This question begins with you reading and reading and reading, or reading to a point of complete understanding. All right. So let's read together. Toolbox A of mass 6 kg. Can you guys hear me? Just to reconfirm. Can you hear me? Make sure we're there. All right. Toolbox A of mass 6 kilogram is joined by an inextensible string to toolbox B with a mass of 4 kg. A pulling force F is exerted on A to accelerate the boxes to the left. The coefficient of friction on the boxes is 0,3 and 0,2 respectively. So we start with A, coefficient of friction, 0,3. Coefficient of friction, 0,2. Both toolboxes accelerate at 5,852 meters per second to the left. All right, let's keep that. 2.1, please, everyone should, if you can't state that, it's a red flag. Please, that's a red flag. Make sure after this lesson, you quickly swat that. And you need to know your first, second, third, and universal gravitation, 4 of them. Draw a free body diagram showing all the forces acting on B. All right, what do you notice on B? All right, can I get responses from you guys? Unmute yourself and tell me the forces you can find on B. Quickly, let's see. Anybody that wants to help? Anybody that wants to help, come quickly. Yes, Michelle? Oh, wait, hold on. I think I'm having a problem with my speaker, so I will not be able to hear. Wait, 1 second. Yep. Just one moment. Michelle, try to say something. Let me see. Are you talking? Okay. All right, I cannot hear you. I noticed earlier on that my time wasn't ringing out. Okay, I'll sort that out. It's fine. You can type in. All right, Daisy says tension, and tension is the force in the rope being pulled by A. So my tension would be to the left-hand side. Oof. That means you guys won't be able to ask. No, I need to sort this out quickly because I need you to ask me questions. Hold on 1 second. Why can't I hear you? You want to remove this selection? No. One second, just want to see something. Where's my playback? I want to make sure that I can hear you. All right. Tra la 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 la. Tididish. Okay, I won't be able to hear you. But if you have, for now, I need to change a whole lot of settings, and I don't have time to do that now. But if you have a question, please just raise up your hand and probably type the question. Okay, I need to deal with this setting later. All right, Matley, thank you. Michelle, thank you. I see a lot of people, thank you, giving me answers, rare answers there, and some already up there. Okay, just walk with me. We have a normal force, we have the force of gravity, and we're going to have our frictional force to the right. And those are the four forces. Please write them in full. Friction, gravity, and normal. So please give yourself 1, 1, 1, 2, 3, and 4. Calculate the magnitude of the pulling force F. So we're looking for F. Guys, always work with the free body diagrams. Even if they don't ask you to draw it. So if I work with A, let's work with B. Since we have B first, I'm going to go to a new page. I'm going to run on this question, so please work with me. Just to redraw that free body diagram quickly. 1, 2, 3, and 4. Okay, so FK, T. These are the two things that matter to me here. Why? The object is moving horizontally. Object is moving to the left, so we take that as positive, and this would be negative. F net is equal to MA. It's tension minus the friction. Oh, but wait, we do not know friction. I see. But what is the formula for friction? Friction is mu Kn. T minus mu K normal equals to MA. Always go back to your free body diagram. Here, my normal, there's one force up, one force down, and normal is mg. Oh, so it's T minus mu K mg. And by the way, we do not know the tension. So let's substitute what we know. Tension minus the coefficient of B, 0,2, and the mass is 4. All right, 0,2, mass is 4, G is 9,8, equals to 4, and the acceleration, 5,852. So we're just doing basic substitution. Oh, this actually gives me my tension. Interesting. What is tension, therefore? You can multiply all of this. All right, let me do the calculation so that we're not taking anything for granted. It is 0,2 times 4 times 9,8. All right, 7,84. And if I move it over to the other side, I'm sure you know what I'm doing. It's going to be positive, right? So plus 4 times 5,582. 30,168. Now that is my tension. But I'm not really interested in looking for tension. I'm looking for force applied. Now go back to object A. Free body of object A would look like this. Normal going up. Similar to B, gravity going down. The force applied is to the left. Now tension would be to the right this time because object B is pulling it, and friction would be in the opposite direction of motion. So force applied, friction, tension, weight, which is mg, and the normal. Similarly, like the first one, we do not know friction. Let me calculate that one out. Times normal force, all right, which is times mg, 0,3, I believe, and the mass is 6, and g is 9,8. I hope this makes sense to you all. If it's not making sense, please do raise an alarm. Unfortunately, I won't be able to hear you. You can just type a message for me, 17,64. But that's not what I'm looking for. I'm looking for force applied. So I'll come back again and say F net equals to MA. Direction of motion is to the left, positive, negative, and negative. F minus FK minus T. All right. What's our friction? We got 17,64 tension, we got 30,168. The mass is 6. And acceleration, we have 5,852, which allows me to now do my calculation. Plus 6. All right, lovely. Then we can put that in a calculator. 13,248. Let me do my calculation again. Maybe I made a mistake. I see your messages now. 4 times 5,852. All right. Plus 0,2 times 4 times 9,8. Let's just check. That's 0,2. Oh, where did I get this one? 30, is this what you got? 31,248. Probably I made a mistake while typing in. 31,248. Okay, let's correct that. Thank you for bringing my attention to that. And then we change that here as well. All right, do you want to give me answers now here? What will it be? 6 times 5,852 plus 17,64 plus 31,248. 84. Is that agreed on? Thank you. 84 newtons. All right, so that's agreed on. Okay, lovely. Then last one, write down the reaction force of the weight. Guys, what is weight? If you don't understand the definition of weight, you will not be able to answer this question. And somebody's saying the force of gravity. No, weight is the pulling force of the earth on an object. So weight is the force of earth on the object. The reaction force, therefore, will be force of object. You just reverse it on the earth. Please take note of that. Weight is the force of earth on the object. Now, if you reverse it, force of object on the earth will be the reverse, and that's the reaction force. Are we okay with that, guys? And that question is done very, very swiftly and quickly. You need to just do a bit of more practice. Okay, let's go pick the next one. Next one would be a momentum question. Oh, this is, all right, let's see. We'll break it down so that we can cover the whole thing. You quickly answer this. Read quickly. Six minutes. All right, guys, were you able to answer? The following graph shows the change in momentum of a truck over a period of time. The truck is initially moving eastward. Now, when they say it's initially, look at the graph. Where is your graph starting from? From here, it means east is positive. So this is your east, east, then it changes, and that will be west. So originally moving eastward, so that will be east, and west obviously becomes your negative. Okay, define momentum. Again, another definition where you're supposed to pick up mass. Very, very important. Product of mass and what? Velocity. Write down the direction of the truck at time t is 30 seconds. Oh, beautiful. Look at 30 seconds. Do you see we're on the negative side already? So what should the direction be? The direction is west. I hope it makes sense. Direction is west. Very important that you learn to interpret before you even start working. All right, so 3.2.1, direction is west. And you get your 2 marks. Magnitude of the net force acting on the truck for the first 10 seconds. Oh, beautiful. Look at this. Where is my first 10 seconds? There. For graphs, I think I once told you, for those of you, there was a day I was doing graphs, you must even have the note. I said, look at the gradient of any graph. How do you get gradient? Change in y over what? Change in x. In this case, what's my change in y? What's on the y-axis? It's momentum. So change in momentum on the x. Ooh, are you aware that that is actually F net? So the gradient here is actually F net. And you can see it's a straight line. So my answer is 0. 0 newtons. Even if you don't know how to do that, you can just simply calculate. I'm looking for F net. F net is change in momentum over change in time. What's my final momentum for the 10 seconds? It is 8,000. Initial momentum, it's still 8,000 over 10 minus 0. I don't know, did that make sense to you? Did that make sense to you? F net is change in momentum. So for the first 10 seconds, you would see that this, so I'm looking at that, final, initial, and that is 0. Explain your answer to question 3.2.2. So we want to now explain what we just did. You know, I'm actually done with the explanation. Just write what I wrote there. That is actually the explanation. So this is 3.3. 3.3. You don't even need to use so many words. Gradient is F net. And F gradient is horizontal, which means it is equal to 0. Look, you are just fine. You are just fine. With just this, you are fine. Okay, so that's the answer to 3.3. I don't need to write any other thing again. That's just beautiful. That is okay. I hope we're good. I'm going to send this PDF to you when we're done in case you missed something. Now, here we go. Let's go get this question, 3.4. We're going to need some information from the graph, but I'll assist you. With the information that we might need. I'm trying to put the graph for you. For this particular one, I'm just going to give you 5 minutes. I want you to try. There we go. Yeah, I think everything we need is right here. All right, start working. 5 minutes for 3.4, 3.4.1, 3.4.2. We're looking at how many marks? 8 plus 4. Oh, that's a lot. Okay, 7 minutes. Try. Give it your best shot. Onati says if we were to write Newton's law of in terms of momentum, would that be correct? Yeah, because they did not restrict you, so it will be correct. You are allowed to do that. But what I would say is use. Wait, which one were you talking about? Anyway, hold on. Let me read your question again. For which question? 2.2.3. Now, in 2.2.3, we were dealing with Newton's laws, right? It wasn't under momentum, so don't write that there. But if you are doing momentum and the question says you should write Newton's second law, you can write in terms of momentum. But if you are really doing Newton's law topic, write it as Newton's second law. Okay, Unati? Do you understand the difference? If the question was under momentum, then you can bring in that. But if it's on its own, under Newton's laws, please just write Newton's second law. Then let's look for trouble. Okay, my child. Yes, Unati? And I was waiting to respond when we start answering your question. She said for 3.2.3, using Newton's second law in terms of momentum would not be enough. You must use the graph. So stating it is not enough. You must use the graph because we want to see where the zero came from. I hope that makes sense. So stating it, it's 3 marks. Stating it, you would get maybe 1 mark. Okay, Nana. All right, let's mark this now together. I'm sure everyone is done. The truck collides with a car at 35 seconds. And you can see the trajectory of movement. If you look at the graph, you can actually see what's happening, the trajectory of movement at 35 seconds. That there's a bit of a change there. You see that 30, 35, there's a bit of a change. The car has a mass of 2,000 kilograms and it's moving at constant velocity of 20 meters per second east before the collision. After the collision, the car has a velocity to the west. All right. Okay, so we have a diagram that looks like this. The truck moving that way, the car colliding that, blah, blah, blah. The acceleration of the truck between T35 and T40 is 4 meters per second east. Calculate the mass of the truck, then calculate the velocity. All right, let's see. Let's first understand the question. We are told that the truck collides with the car at t equals 35. All right, the car has a mass of 2,000. So the mass of the car is 2,000. So we can put a picture to this. Moving at a constant velocity of what? In the initial velocity of the car is 20 meters per second east. Okay? And east is positive. After the collision, the car has a velocity to the west. Final velocity of the car is unknown, but we know now it goes to the west. The acceleration of the truck between T35 and T40, that is during the time of collision, the acceleration of the truck is 4. Calculate the mass of the truck. All right, we don't know the mass of the truck. Lovely. Let's see something here. This is very, very interesting. Okay, if I'm looking for acceleration, you know what I would do? If I look at this, I would simply say that F net is equal to what? MA. I know my acceleration. If I want the mass, I need to get F net. And the question is, how do I see what this examiner is up to. Let's see. How do we get the net force here? This is very interesting. What is it that we know? Don't forget, we can still work with the graph. Let me go to, we have this information, right? Let me get to a fresh page where I can think. We said, I need to get F net. Oh, wait. F net is change in momentum over change in time. Okay. But let's see something here. By the way, they told us, do we have time? They said between T35 and T40. So my time of collision is what? 5 seconds. Beautiful. All right. Our time of collision is 5 seconds. Do we then know the change in momentum? Please look at the graph again. The graph is where we need to look at. Between T35 and T40, our initial momentum is negative 60,000 and our final momentum is 40,000. That's why I said you need the graph. Do you see that? Initial is negative 60 and final is 4. Okay, will that help? Because I think that should help us get our F net. Check. No, what am I? All right, final momentum minus initial momentum over the change in time. Our final momentum is 40,000 minus our initial momentum is negative 60,000. Be careful with the zeros over the change in time is 5 seconds. Oh, do you notice we can get Fnet here? Do you want us to do the maths? Somebody do the maths for me here. That's 100,000 divided by 5. That's 20,000. Oh, Fnet is 20,000. But remember, Fnet is MA. Oh, beautiful. Oh, let me do it this way. Fnet is MA. 20,000. We don't know the mass, but we have the acceleration as 4. If you divide 4 by 20 would give you 5, so it's 5,000 kilograms. Did that make sense to you? We used the information. Now, I couldn't use anything from the car because the final velocity of the car is still missing. All right, let me see. Somebody give me a thumbs down. Who gave me a thumbs down just now? Can you give me that thumbs down again? I want to see because I want to make it personal. Somebody gave me a thumbs down just now. Ooh, that was fast. Okay, but let's look at it again. Do you want to tell me where you lost? Because if I look, all right, sir, may you please, all right, Tato, I'm going to quickly do that. So if I look at the information I have, the information I have doesn't look sufficient. Why? I have a missing value. I have that is missing. And I told us, okay, look, because they gave me acceleration, instantly they want the mass. I need to quickly connect. Fnet should be equal to what? MA. If I have my acceleration, if I can get Fnet, I'll be fine. How do you get Fnet? Fnet, according to Newton's second law, Fnet is what? Change in momentum over change in time. Where did my collision start from? 35 seconds to 40. So that becomes my initial momentum, and that becomes the final what? Momentum. Tato, is that fine with you? Do you understand what I just did there? If you get that, then we're good. So my initial momentum in the highlighter is that negative 60, and my final is that. So if I use this, I'll be able to get my Fnet, and that's what we did. Fnet is change in momentum over change in time. 40,000 minus 60,000, that gave us our Fnet. But what is Fnet? Fnet is equal to MA. You just bring in things together to give you a solution. I don't know if that makes sense now. So always analyze, ask yourself, what is it that I have? That's why you would see, if I want to do any physics question, I always make a list. That list will always guide me to say, okay, this is what I have, this is what I need, this is the formula, and this is the way. With this now, we can calculate the velocity of the truck before the collision. We want the velocity of the truck before the collision. I think we can still use momentum. We can actually use the momentum because look here again, we know the initial what? Momentum. And we want the initial velocity. Oh, sweet. Very sweet now. Initial momentum. So what do we say? Momentum is mass times what? Velocity. What is our initial momentum? Negative 60,000. What is the mass? We now have the mass, 5,000. No, that's 50. And we're looking for V. All right, if you put that in a calculator, what are you getting? Anybody? 1, 2, 3, 1, 2, 3, 560, that's 12, negative 12. So it means the velocity is what? 12 meters per second west. Remember from the beginning, we stated that east is positive. Beautiful. Everybody okay there? Please let's ask, I don't know, I'm really feeling very bad with my speaker not on, so I can't hear you. It looks as I'm the only one talking. I would have loved to hear your voices. Yeah, I'm just talking to me, only me. I normally like a very interactive class. All right, the last one. The sum of the kinetic energy of the car and the truck after the collision is that. Prove by means of a calculation whether the collision between the car and the truck is elastic or inelastic. Okay, quick revision. What is elastic collision? What is an elastic collision? An elastic collision is a collision where both momentum and kinetic energy are conserved. It means that initial momentum, total initial is total final, and total sum of kinetic energy before is equal to that. So if those two conditions are met, then we can talk about an elastic collision. But what information were we given? We were told something very important. The sum of the kinetic energy of the car and the truck after, oh, beautiful, is 1,06 times 10 to the power 6. All right. Sum after is 1,06 times 10 to the power. All we need to do is to calculate the sum of kinetic energy initial, which will be half m car, initial velocity of car squared, half m truck, the initial velocity of the truck squared. What is the mass of the car? Oh, that's why they gave us this information. Nah, I see. 2,000, and the initial velocity is 20. That's why I was wondering, where are we going to use that? 2,000 and then 20 squared plus half. Mass of the truck, I think we got what? 5,000, and the velocity is 12. And the initial velocity is negative 12. All right, let's throw that in a calculator quickly. All right, anybody throwing that, you can also go ahead and do it at an, okay, that's my calculator now. All right, so what do we have? 0,5 times 2,000 times 20 squared plus 0,5 times, I'm just lazy with the half. That's why I'm typing that. 12 squared. 760. 1, 2, 3. 760,000. So do you think it is elastic or inelastic? Oh, wait, there's a message here. Sir, after this question, please just go back to 3 and explain one more time. Oh, Lord, okay. So what do we say? The kinetic energy initial is not equal to the kinetic or sum. Therefore, collision is inelastic. Collision is inelastic. T, could you tell me where exactly you were lost? If you can tell me exactly where you are lost, I can find you easily. It will help me to find you easily. Onati, what are you saying? Why we used negative 60,000? All right, so they were told that the collision, the truck collides with the car at t equals to 35. And you would see that is where the change occurs. That's 30, that's 40. So that's, you see this line here, that is the time of collision between 35 and 40. And at 35, momentum is that. At 40, momentum. Collision occurred here, initial momentum and final. So this is my momentum before the collision, and this is my momentum after the collision. T. I don't know if that makes sense. All right, they said 35 and 40. 35 and, so you see, whenever you see this line here, that's the time of collision between two objects. And the gradient would actually give you net force. So that's why we use that negative 60,000, because that's our initial momentum. All right, and the final one, inelastic. I hope everyone is okay with the last one. Everybody okay? So just knowing your definitions and when to apply them, really, really important. Okay, let's go to the next one. You can download more papers and just walk through. All right, let's see. VPM. There was a lot of cry about VPM. Okay, let's break it down. And you want to try that for me quickly. 2, 2, 3, 5. That's 12 marks. Okay, I think 10 minutes should be fine. Get your formula page, get your calculators. Oh no, calculator, not time. 12 minutes, quickly walk through for me. Give it your best shot. Let's see what you can get. Okay, I'm sure you are done somewhere. Can we mark this quickly? All right, Unati. A hot air balloon is moving vertically upwards at a constant speed of 12 meters per second. A camera rather, is accidentally dropped from the balloon. Now, I remember explaining to you guys about the word dropped. That drop doesn't mean that the initial is zero. We must ask ourselves, what is the position or what is the condition from where the object was dropped from? All right, so a camera is accidentally dropped from the balloon at a height of 100 meters. Meanwhile, the hot air balloon was moving in which direction? Moving up at a constant velocity of 12 meters per second. All right. Is the hot air balloon a projectile while it is moving upwards? Our answer would simply be no. And the question is why? Now, if something is moving at constant velocity, it means that the acceleration of that object is zero. All right? Acceleration of that object would be zero. Why are you putting a sad face there? And for something to be a free fall, acceleration must be what? 9,8. So they said, give a reason for your answer. The acceleration is zero. For it to be a free fall, acceleration must be 9,8. Guys, are we okay there? Constant velocity, acceleration is zero. Free fall, acceleration is 9,8 meters per second squared downwards. Please respond. Give me thumbs up, thumbs down. You're not okay with what I said. All right. What is the velocity of the camera immediately after it is dropped from the hot air balloon? The velocity of the camera, I just explained that, is 12 meters per second upwards. Please take note, the camera would go up before coming down, according to Newton's first law of motion. If I were to draw the motion of the camera for you, this is what you're going to expect. Newton's first law of motion says an object will continue in its uniform motion unless acted upon. All right. So it goes up first at 12 meters per second. It reaches maximum height there of 0, and then calculate the time taken by the camera to reach, its maximum height. Okay, let's see. Michelle, okay, you are still fine. You can say gravity is not the only force, but you must tell us the other force. The hot air balloon has an applied force acting on it. Okay. Hot air balloon has an applied force acting on it. All right. Calculate the time taken to reach its max. Oh, beautiful. Guys, we are working. Please always check. There must be a frame where you are working at. Your start and your stop. All right. Let's pick upward as positive. The initial velocity is 12. The final velocity is 0. But your acceleration, which is always acting downwards, will be negative. Because we chose upward as positive, downward will be negative. We're looking for time. I think we have a formula. Plus A delta T. 0, 12, plus that, and that. Move that over. Please don't add. Don't add 9,8 delta T and 12. They are not like terms. Divide both sides by 9,8. Does anybody have an answer for me? Please, we do not add. I've seen some learners do that and then they add. 1 comma something? Thank you. All right, Nwabile, you want to talk to me quickly? Or you can't talk to me, just type. Something's wrong with my speakers here. So Nwabile, if you can quickly type. Guys, I am seeing some of us are not rounding off correctly. I'm seeing 2-2, I'm seeing 2-3. Make sure to be safe, wanted to use 3 decimal places. No, standard is 2 decimal places. And if it's 225, then it becomes 23. 2 decimal places, everybody. Please, let's round off correctly. 1,2, no, 12 rather. 12 divided by 9,8. 1,222. Oh, it's 224. Where did Michelle get the 5 from? 224. So it's 1,22. All right, Nwabile, your question, sir. You said the acceleration is 0. Nwabile, that means you missed me somewhere. The acceleration of the hot air balloon is 0. The hot air balloon is not a free fall. Let's go back to question 1. Is the hot air balloon a projectile? And the answer is no, because we're told that it was moving at constant speed. All right? When an object is moving at constant speed, the acceleration of that object is 0. But where's the camera? The camera is out of the hot air balloon. When the camera was in the hot air balloon, the camera wasn't a projectile. It only became a projectile when it left the hot air balloon. Are we okay? Yes, the question, that 0 was only for the hot air balloon. We awesome now? Awesome, great question, I love it. All right, 4.4. Calculate the distance between the hot air balloon and the camera when the camera is at its maximum height. All right, this question needs a bit of some diagram. Please sketch, it will really assist you. So, this is the ground. The hot air balloon was here, and the camera was released from it. So the camera went up. The camera went up vertically and down. All right. But what happened to the hot air balloon? The hot air balloon kept rising vertically. Are we okay there? So please take note of that. That is the hot air balloon. It kept moving up, and this is the camera. The question says, calculate the distance between the hot air balloon and the camera when the camera is at its maximum height. Oh, beautiful. It means from here to here, let's call it A to B, the camera has traveled. Camera has traveled 1,22 seconds. Meanwhile, the hot air balloon too is still moving on. Oh, beautiful. So the hot air balloon is also here after the same time, 1,22 seconds. How far is the hot air balloon now? I hope that makes sense. The camera dropped and traveled for 1,22. The hot air balloon is still also moving for 1,22. Let's calculate that where the position. Delta Y equals to VI delta T plus half A. This is for the hot air balloon. We chose upward as positive, 12. This is 1,22. But for the hot air balloon, our acceleration is 0. I hope that makes sense. Does that make sense to you? Or the hot air balloon? Please respond to me. Let me know if what I just did makes sense. That's not the final answer, but I want us to move together. Amatle? All right, I've got 2 questions there. Amatle gave me a thumbs down. And Kim is asking, why is the time? All right, you got to read 14,64. Let's go back. Please, we've got to read. It says, calculate the distance between the hot air balloon and the camera when the camera is at its maximum height. How long has the camera traveled for? The camera, from when it came out of the hot air balloon to reach its maximum height, it had traveled for 1,22 seconds. It means the hot air balloon is also traveling for 1,22 seconds. I don't know if that makes sense now. Okay, I just answered the question now, Amatle, and okay. I don't know if it makes sense. This camera traveled for 1,22. We want to find out from it traveled 1,22 to get here. The hot air balloon is here. What is the distance between the hot air balloon and the camera at this time? How long has this is where they departed from. They departed and the camera went 1,22. This one also 1,22. Where is this when the camera is at the maximum height? So I'm using that 1,22. Let me know if it makes sense. It's the same time of travel. So you've got to read. That's why here is the key. It says when the camera, when talks about time. Okay. But the question now is, okay, we have that 14,64 from, remember, we are looking for this. This is the height we are looking for. Let me mark it. We are looking for this difference. Let me use a yellow. This is the main thing we are looking for. The distance that we are looking for. Because camera is at the maximum height. And, all right, so from the point where the camera was released, we said the hot air balloon has traveled 14,64. I'm going to make this very simple for you on the right-hand side for you to be able to follow through. Please watch. I'm going to reinterpret the whole thing now. Let me do this like this. Let's do this like this. All right. From that top, the hot air balloon went up, and the hot air balloon, so this is 100 meters. The hot air balloon has now gone 14,64 from here. It means the total height here. I don't know if we need this, but I just want you to see 114,64 from the ground. Okay. Now, where is the camera? The camera is at its own maximum height, which is somewhere here. The question is, we don't even know how far the camera has gone. Remember, this is the distance we are looking for. So let's look at the camera. What is the maximum height that the camera has reached? Camera. I think we can use, can we use the same for, yeah, we can use the same. Delta y equals to vi delta t plus half a delta t squared. What's the initial? The initial is 12. The time of travel is 1,22 plus half. Our a now is negative 9,8 because it's a free fall. Remember, we chose upward as positive, and g is always acting where? Downward. So what is the distance that the camera has traveled? 12, 1,22. Please, this is where your signs are very important. Negative 9,8 and 1,22 squared. Confirm, are we getting the same answer? 7,346. All right, don't round off yet, we're not done. 3,468. Okay, let's look at what we calculated. The camera has moved 7,346 14.8. The hot air balloon has gone 14.64. What is the distance? If you just consider this section only, consider this only, this blue, I don't know if you can see it, or let me erase so that you'll be able to see. Look at what we're looking at. Yeah, I think that's better. The total height, the long height is 14.64. Daisy, in this case, you should use the rounded off time. You take the final answer from the previous question and carry on. The only time we don't round off is if I am within a calculation. You see, like here, I am within. So the standard of physics is we got our first answer, 1.22. Take that answer and work with that one. You don't need to use the original unrounded off answer anymore. That's the principle. I hope that's clear. So here I'm allowed to use my 1.22 because I was done with it. But now here you see I'm using my non-rounded off answer because I am still within a calculation. 14.64 minus 7.3468. Now I'm going to round off my answer to 2 decimals because I'm done with this calculation. 7.29 meters. Talk to me, people. Any question here? The distance between the two. Look at the diagram on the right. That should assist you in complete understanding. Talk to me. Thumbs up, thumbs down. Ask your question. Sir, for the hot air balloon, if I use the distance formula, would it be wrong? No, it will not be wrong. It will still be correct because your A is 0. So distance is speed times time. Will still work perfectly. It will give you the same answer. Come talk to me. I only got about 3 responses. And we are close to about, how many are we in this session? Quite a big number, 32. Priscilla. I don't think I know that face. Do I know that face? Priscilla. Priscilla Adeyeye. Interesting. Michelle, what do you mean by the distance formula? Why are you guys laughing when I said Priscilla Adeyeye? That's very interesting. Adeyeye, that's my little girl there. Next time I want to see you. Daisy, why are you all, guys, why are you all laughing? Okay, Derato. Michelle, 12.25. What do you mean? Did I make a mistake? When you say distance formula, what do you mean? Speed equals to what? Distance over time. So what is distance? It is speed times time. What is your speed? Your speed is 12. What is your time? 1.22. And that's that. So I'm not sure of where your 12.25 is coming from. Michelle, for the hot air balloon. Yeah. And that's the only formula. All right. Lerato said I should re-explain the distance calculation. All right. Lerato, I need you to give me a quick response. Are you okay with 14.64? Guys, please don't start with me here on this Adeyeye thing. Don't start. You are not going to finish this. You are not going to finish. It's pronounced No ways. Except, Priscilla, please can you, wait, we are pausing physics now. Priscilla, we're pausing physics. I need to sort this out. Priscilla, please talk to me. Where are you from? I'm pausing physics until Priscilla responds. Priscilla, where is that child? Oh my God, why is my speaker not working? I feel I can just restart. She's from Lagos. She's from Lagos. If she's from Lagos, it is Adeyeye. All of you telling me that the day, you guys, you don't even know the way to the airport. If she's from Lagos, then it's Adeyeye. Excuse you. Some of you don't even have passports. All you have is a birth certificate, not even an ID, birth certificate. You're telling me the D is not. Let's go back to physics until I come back to Glenvista. We'll sort this out. Yeah. Okay. All right. Let me go back to Lerato. People that don't have, they only have birth certificates, that thing from Home Affairs, they're telling me I should not put DE. For somebody who's from Lagos. Ebanna. How? Nyadelela. Okay. All right, guys. Oh, I'm really missing my speakers. I'm missing my speakers. It's been a very lovely class. But anyway, Lerato, are you okay? You said you're okay with 14,64, right? Are you okay with 7,3468? Rato? If you're okay, then check. Lerato, we're just good. If you're okay with that, look at what we have here. From here to here, 14,64. From here to here, 7,34. What is the remaining distance? This minus that. Case closed. Rato? Look at the diagram in the blue box there, Lerato, on the right-hand side. Tell me if you are okay with that. I know the distance from here to here, 14, and I know the distance from here to here, 7. I can always get the remaining distance. Sweet, beautiful. All right. And where is Priscilla? Priscilla is absent. Oh, she just logged in. She's watching Netflix somewhere else. Okay, we'll catch her. Logged in and watching Netflix. All right, let's quickly answer this. I won't give you time. I'll just quickly answer it myself so we can then get into the chemistry part. Chemistry, I think I'll just do reactions with you guys. I'll just do reactions with you. No. It's either no, but it's what I'm seeing here is Adeyeye. And that is a Yoruba Nigerian name. And if it is Adeyeye, we are actually from the same place. So you guys, please. Just leave, let's leave Junior alone. We'll deal with him. All right. Look at this. A jogger running at constant speed of 3 meters per second is 15 meters away from the hot air balloon as shown in the diagram. Okay, let's look at the diagram quickly. They said there's a jogger somewhere. That's Junior. All right, Junior there now is 15 meters away. That's Junior. Okay. I was going to say Kevin, but that's Junior. All right. If the jogger sees the camera at the same instant it is dropped from the balloon, will he be able to catch the camera before it strikes the ground? Will he be able? No, she's not able. She's not able. Daughter, that Priscilla girl, I need to find her. We're going to continue this on because I'm going to do a video call. I need to see Priscilla. She's not at all. Yes, Mtanami, please find that Priscilla for me. Okay, but let's finish, guys. Let's finish. All right. So what do you think we should do here? So this camera, let's check something. This camera, I hope you understand the scenario. That's what physics is all about. Physics is all about painting a practical picture of what's going on. So the camera dropped, all right, but the camera first went up, like we said, Newton's first law came down. Can this guy rescue the camera? What I need to do is to calculate the time, all right? Is to calculate what? The time. Okay, let's leave Priscilla. We're going to find her. Don't worry. She can't run forever. We all know her except me, okay? And somebody that wants to spy on her, please just send a picture of her on the group. All right. But anyway, please, let's finish physics. All right. So the idea would be, how long will it take the camera to reach the ground? And how long will it take this guy to reach this point? That's what we need to calculate and compare. How long will it take? Guys, quickly, can I ask you to do that for me? How long will it take the camera to reach the ground? And how long, let's do that first. Part one, how long will it take the camera to reach the ground? Everybody, quickly, I'll redraw the diagram for you here for you to see. Let's do that very, very fast. There we go. The height here is 100 meters. Initial velocity is 12 meters per second. Please calculate the time it will take the object to reach the ground. Let's calculate that very fast. Put your answers in the group once you are done. Haibo, Unati, negative time. Mark yourself wrong. You did something wrong. Amat, they also got negative. Guys, once you get a negative time, something is wrong. Tato, also negative. I'll tell you what you guys did wrong. I know where you guys missed it. No, Nati, we are calculating from here, from when it was dropped. I know where you missed it. Don't worry, I'll fix you now. We chose upward as positive. What are the things we know? The initial velocity is 12. So we're looking for, from time here, A to B. What is my displacement? My displacement is negative 100. That's where you missed it. Most likely. I got you, right? Guys, why is it negative? The shortest distance from A to B is you're coming down. Upward is positive, downward is negative. G as well is negative 9,8. So what do we know? Delta Y is VI delta T plus, and this is the only formula I can use. I cannot use VF. Negative 100, 12, let's just say 12T plus that negative 9,8 T squared. What do we have? Negative 100, 12T minus 4,9 T squared. All right, if I move all of that, 4,9 T squared minus 12T minus 100 is 0. We use our quadratic formula. You are going to get two answers and you discard the negative one. minus b, which is minus negative 12 plus or minus square root of. Please put that thing in a bracket when you are putting the calculator. Minus 4. My a is what? 4,9. And my c is a negative 100. Close the bracket. And then 2 times 4,9. All right, 5,91. Let's check the other one. Yes, it's a quadratic, Nana. Do you see the other one is a negative? We cannot use time as negative, so 5,91. It takes 5,91 seconds for the camera to reach the ground from the moment it was dropped. Meanwhile, the jogger, Junior. Let's see, what do we know about this Junior guy? All right, a jogger running at a constant speed of 3 meters. You see, constant speed of 3 meters per second, but 15 meters away. Okay, let me see. Sir, should you also consider the time it took for the camera? No, that is what we mean by displacement now. We don't consider that time. That's why it's a vector quantity. All right, why is it negative 100 again, Lerato? From point A to B, we are coming down. Do you see my arrow? And we chose upward as positive. But A to B, we are going down. That's why it is a negative. Lerato, are we okay? And Michelle, are you okay? So we use vector quantity. I have somebody giving me a thumbs down. What is the question? Michelle. Here's another one. Michelle Uga. Another one here. Michelle, where are you lost? Oh, it was a mistake. Okay. I need to know all your faces and names now. Michelle. There's another one there. Another blood running there. Another blood running. Okay. All right. Now, let's look at the jogger. What do we know? The velocity of the jogger is constant, 3 meters per second. And the distance, delta x, is 15 meters. Now, because they said it's constant, acceleration again is 0. I just want to emphasize that. Can I get my distance? I can use this formula, VI delta t. All right, I can use this, or I can use the distance one as well. This is 15. What's our velocity? 3. I don't know the time. Plus half. I'm using this because I want to emphasize the 0. Why 0? Constant what? Velocity. So I have 15 equals to 3 delta t. What is my delta t? 5 seconds. All right, the jogger will get to that point in 5 seconds, and the camera will drop at 5,91. Do you think the camera will be safe? Entle, what's up? You said, oh no. Oh no to what? Onabile, you gave me a thumbs down. Oh, why is my speaker not working today? Guys, will this guy be able to catch the camera? Busa, the camera will be safe. Okay, Entle, you got it right. The guy with the camera, this guy got there 91 seconds before the camera reaches the ground, so the camera is safe. Or 0,91 rather. How did they ask us? They said, will he be able to catch the camera? Yes. Support your answer with a calculation, and that's it. Yes. The guy arrives at the point at 5 seconds, and the camera would only reach that point at 5,91. If you use the speed time, yes, you're still fine, as long as acceleration is 0. All right, so distance or speed equals to distance over time. You will still get the same thing. So my speed is 3. I don't know the distance. No, sorry. I know the distance as 15, and I don't know the time. Cross multiply. So you would see t is still what? So like I said, I was just emphasizing the acceleration part of being 0 when I see it, the word constant speed. Are we okay there, Nati? Esther. Esther Unat. I don't know why she shouts Esther, why she's so excited about it. I'll find out one day. All right, everybody okay? Yeah, we'll find out one day. That chat just gets high. Because establish. Okay, you're losing me more. Because establish. Okay, we'll find out. Where is establish coming from? Guys, can we draw? Everybody, quickly give me an attempt. Draw a sketch graph of velocity time graph for the entire motion of the camera. I'll give you quick 2 minutes to try that, or 1 minute. Everybody, the velocity time graph of the camera. Then I'll quickly help you in, guys, I'm only going to do organic reactions. I hope that will be fine. All right, a velocity time graph. To draw the velocity time graph, I told you to use your sketch. Your sketch is always a very good point to start from. So if I want to use my sketch, we started from 12, we went up, and we came down. So it's 12, it's 0, negative 12, and we don't know what that velocity is. And we don't really need it. So what are the velocities I know? I know 0, I know 12, there's negative 12, and there's a negative something, something I don't know. We started from 12, we got a 0, it came to negative 12, and a particular velocity. Can you see? It's just a straight line there. Just a straight line. Velocity in meters per second, time. And because we calculated our time, we can actually put that time here. We got 5,91. And please label your graph. Velocity time what? Graph. We chose upward as positive. And that would be your graph. Let me see something quickly while I know you want to draw. Indicate the initial time and time taken to reach the maximum height. Oh, we got that. What was that time? 1,22. We should show that time of 1,22 as well. All right, and that's it. I hope everyone is okay. All right. I am quickly going to help you with organic reactions very, very fast. And we would apply whatever I'm going to tell you now in the question that we're going to find in this paper. So please, I want you to listen carefully to I'm going to make it very snappy, very short, only 1 page. for organic reactions. Only one page. So please follow me very closely. Okay, I might use 2 pages. There are 5 reactions I need you to know. Number 1, combustion reaction. Let's run. Number 1, combustion reaction. Your alkanes, your alkenes, your alkynes, and your alcohols. All of them can burn. When we talk about combustion, we're talking about burning. And they can all react with oxygen to give me the same product, carbon dioxide and water. That is combustion reaction, when something is burning. And you must learn how to balance. Most of the time, we are only tested on alkanes. So let's look at first example. C2H8. No, I'm lying. 6 plus O2. I already know my product. CO2. Your job is now to balance. I'm sure we can balance. Balancing, you're just counting. And for me, when I want to balance, for whoever taught you this, for me, when I want to balance, I always start by putting a 2 on the left-hand side. So what I'll do is, I'll put a 2 here. Somebody says, should I always do that? For me, yes, only for this reaction. Once I put a 2 there, you know what that means? It means my carbon is now 4. So I'll go to the right-hand side and deal with the carbon. Carbon is 4. Lovely. First one is done. Second step, look at your hydrogen. There's a 2 times 6. But on the right-hand side, there's a 2 already there. Oh, all I need to do is to put a 6 there. To now make it 12. Do you see that it's automatically balanced? It's 2 times 6, but on the right-hand side, we just reverse it. All right, and it is automatically what? Balanced. What is left is oxygen. Now, how do I get the oxygen? What I need to do is to look at my oxygen here. 4 times 2 is 8. And the 6, that's 14. So there are 14 oxygen atoms on the right-hand side. I have a 2 here. All I need to do is to put a 7. And it is balanced. All right, so alkanes, alkenes, alcohols, all will combine with oxygen. Let's do one more, guys. If I have C3, just want to show you something different here. Plus O2. I'm going to follow the same method very fast. Put a 2 there. 2 times 3 would be 6. My hydrogen is now 2 and 8, but I already have a 2 here. So I'll put my 8 here. Now, what is 6 times 2 there? 12 plus 8 would give me what? 20. It means I should put a 10 here so that it's balanced. But look at these numbers. I've got a 2, 10, 6, and 8. The coefficients. They are all even numbers. I need to reduce them by dividing by 2. So the correct thing will be C3H8 plus 5O2 to give us what? 3CO, because it must be a ratio. The first one I didn't divide by 2 because it's a 7. There's a 7 there. But the second one I'm dividing by 2 because I can divide all across by 2. Are we okay with that, everybody? Reaction number 2, cracking. Cracking, not to be on crack, guys. When I say cracking, cracking means, hey, I know you were going to laugh, please. Not to be on crack. We're not doing organic for you to start cracking. When we say crack, crack means we are breaking something, making it smaller. Please go and check the definition of cracking. I'm running. It is the breaking down of long hydrocarbons into smaller, usable units. That definition is important. Now, there are 2 reactions in cracking. 2 reactions. We are going to take a long hydrocarbon and break it down into a smaller alkane plus an alkene. And this one is so simple because you're just counting. For example, if I give you this and I tell you to find X, you're just going to count. That's all. You're just going to count. I have 3 carbons. So what will this be? C7. And what is 22 minus 6? That's 18. So that's my this one is now my alkane, and that's my alkene. We're done. Second reaction, our long hydrocarbon, and the examiner is not going to, you'll see it, they will write it out for you, alkene plus alkene and hydrogen gas. Once it is 3, it is alkene, alkene, hydrogen. They'll give you where to start. They won't leave you flying blind. Check this. Let me, C4, H8 plus Y plus H2. If you just do the math and add and subtract here, you will be done. What is 10 minus 4? 6. Now, hydrogen, I have 8 and 2 already. That makes it 10. 22 minus 10 would be 12. Case closed. We are done. Are we okay there, everybody? I'll just put a little note here for you under cracking. We can have thermal or we can have catalytic. Catalytic means we use a catalyst. And thermal means we use high temperature and pressure. High temperature and pressure. Wonder what? Oh yeah, 16. 16, thank you. Meth is not methane, it's a Sunday. All right, guys, everybody okay with this? Lerato, stop laughing. Laughing at me. Meth is not methane. It's all that crack. My daughter. It's all the crack. Yeah, your teacher's on crack. I'm on crack. I'm cracking something here. Okay, guys, let's look at let's look at the next one, which is gonna be the main ones. Are we okay here? Moving. Now, for this one, there are, I said number 3. There are 5, right? Number 3, number 4, number 5. I'm gonna look at them together. Substitution, addition, and elimination. Substitution, addition, and elimination. Now, I am going to explain this to you in a very, very simple way so that you would be able to understand it very quickly. All right. In a very, very commonly simple way for you to understand this. So I'm going to tell you a quick little story. All right. Just going to tell you a quick little story. Going to tell you a quick little story here. And I will be dealing with all the reactions when I tell you this story. So, I will tell you a story that says that before I got married, guys, I was single. Duh, no one was born married. Okay. If you were born married, we should arrest you. Okay. So, if you were born and you came with a wedding ring, something is wrong somewhere. So, before I got married, I was single, and I was not just single. I was single and I was seriously searching. So please remember the story. I was single and I was what? Seriously what? Searching. It was so serious. You know, I went on date my same winner, same. Guys, things are coming out tonight that we need to keep record of. Entle is married. Wow. Okay. Entle is married. Anyway, I was single and seriously searching, and it was so serious. I went on date my family? I don't know. Date my family, date my neighbor, redate my ex. I went on all kinds of programs. Okay. Until somebody said, "Hey, dude, there's a girl, but she's in the United States of America." So I traveled to the not now, guys. I'm not going now because they are bombing now. Please, not now. I went long ago. Yes, to me, because it was serious. I went to date my ex, and exes are deceiving, eh? Thank you, my daughter. Exes are deceiving, so I can't redate my ex. They are deceiving. So I went to the United States of America before them and Iran started their thing. And I met a beautiful lady there, my chocolate banana fruit cake. And her name is Susan. But I don't call her Susan. Why are you all laughing, guys? Why are you all laughing? It's my chocolate banana fruit strawberry cake, all mixed in one. And I don't call her Susan. I call her Sue, baby. Sue. I wanted to see this story again. I'm going to repeat. I was single, seriously searching. I went to the United States of America, where I found this gorgeous, beautiful, godly, God-fearing, ever-smiling, vivacious, African, beautiful lady. I'm even looking, I need to check AI now to give me some good loving. Oh, somebody said amen. Tato said amen. Oh, Lerato is clapping. Beautiful. All right. And her name is Susan, but I call her Sue. Sue babes. Okay. Now, quickly check something. So Bishop weds Sue. It was a global wedding. But because there's so much chemistry between us, the chemistry is so deep, you know, we think alike, we do a lot of things. We see you, the African Shakespeare. Junior, calling me an African Shakespeare. I'll catch you when next I come there. All right. But because there's so much chemistry, look at what I did to words. I did not write words because the chemistry was so much. She's my oxygen. She's my carbon dioxide, everything mixed together. Okay, all right. I wrote CEDS, C for chemistry. My good learners, if you can remember this, you are done with organic reactions. Let's put a full meaning to all of this. So, if I move from a saturated to another saturated compound, that is a substitution reaction. So if my reactant is saturated and my product is saturated, it becomes a substitution what? Reaction. If I move from an unsaturated and the product is a saturated, that becomes an addition reaction. And then if I move from a saturated to an unsaturated, it becomes elimination. Look at how chemistry can be done so easily. Look at how chemistry can be done so easily. Saturated, saturated substitution, unsaturated, saturated addition, saturated, unsaturated elimination. But somebody's saying, but what is this CEDS? I'm going to give you that quickly now. And you would see I'm going to answer a question using this. The CEDS stands for, remember what our E stands for. E stands for what? Elimination. And S stands for substitution. That one will not change. What about the C and the D? There's a note here. Oh, thank you, Mwabile, for promoting. Yeah, thank you. By the way, these are all on the cue cards. Those of you that think you are saving, not buying cue cards, check. You should have done this long time ago. It's on card number 23, I think. If I remember, Mwabile, just, they don't know what they are missing. They don't know what they are missing. All right. C. What does C stand for? C stands for a concentrated, strong, I'll write base for now. Example, KOH. So every time, these are called reaction conditions. And D would stand for dilute, strong base. So if I am eliminating, I'm using concentrated. If I am substituting, I'm using dilute. And the final thing here is for elimination, I need strong heat. While for dilute, I need mild what? Heat. Then I'm going to give you 5 reactions and their catalyst. Or let's use a table. Reactions and catalysts. And this will answer all your questions. All I need to teach you is how to apply them. All right, guys, let's run quickly. I'm sure you are all now tired. It's been from 4. It's been from 4, but it's been good. I hope you learned 1 or 2 things, guys. All right, what are the reactions? Number 1, hydrogenation. What is hydrogenation? If I am adding hydrogen, it's a nation of hydrogens, all right? And that will be platinum. Number 2, halogenation. They are all on the cards. That is sunlight or ultraviolet ray, UV. Number 3, hydrohalogenation. Here, I must have no water. Number 4, hydration. And hydration is simply from alkenes to alcohols. What do I need? I need phosphoric acid plus excess water. Yeah. And number 5. To me, you don't have a choice. In fact, this is a simpler way than whatever you would have been taught. Number 5, esterification. Ester. Concentrated sulfuric what? As you have to cram this too. In fact, this is the simplest. And by the way, are you aware that you don't need to cram this? You just need to remember the story. That one is, you are single and seriously searching to me before you went to the United States of America. Let them finish the war before you go. Then you would find a girl called Sue, or you'd find whoever you want to find that is called Sue. And that's all. That one doesn't need any cramming. That's a very simple thing. And I gave you how to remember said words. Concentrated, elimination, dilute. So this is what you need to cram. Just 5 lines. And all you need to do is to write it over and over again. To me, can relate because they are single and seriously searching. Yeah, so, you know, as long as you're not searching in grade 8. Don't go and search in grade 8. Please stay in grade 12. Guys, please leave my daughter alone. Please leave my daughter alone. Oh, maybe some don't know that you are my daughter, Nati. They were not in class. I requested for that video. There was someone who recorded. Just I don't know the names. Was it Pumzile? Amatle, what favor? Oh no, there's Amatle. No, it's not like that. It's not like that. It's not like that. It just happened. And we just went on with the chemistry, you know? Okay. Anyway, someone recorded that video and it would be nice to just send. Unati loves kids. Please tell me everything about that child. Tell me everything about my daughter. All right, guys, let's finish up. There are 2 important rules. Yeah, I think she learned about cracking. That child, she's always on crack. I need to find a medicine for her. Or is it Pumzile? Pumzile, if you recorded it, please let's share that video with me. We can learn from it. All right, guys, so please, to me, you need to learn this, okay? You need to learn this, and you would see what I'm going to do now. Maybe if I use this in answering questions, it's going to inspire you to learn. All right, quickly, guys. Markovnikovs and Zaitev. You don't need to know the rule. You just need to know that the rules. Markovnikov's rule. Markovnikov's rule. And this guy simply says that the hydrogen atom will be added to the carbon that has more hydrogen. And to simplify that, we just simply say the rich gets richer. Enze, like father, like daughter. Okay, all right, no problem. Markovnikov's rule. So we just say the rich gets richer. I'm going to show you how that works. Rich gets richer, and if that's the case, the poor also gets what? Poorer. So that's just a simple illustration on how to use the rule. Guys, and I will be done with reactions. Can we pick one question to do together very quickly? Guys, please leave our family alone. By the way, saturated and unsaturated, quickly. Please leave our family alone. This one here would be alkane. This would be haloalkane and alcohol. And for unsaturated, guys, we are going to be working with alkene most of the time and alkyne once in a while. So all the reactions are you trying to move from one to one. Either you move from alkane to alkene, alloalkane to alkene, alcohol to alkene, or you move back, or you then move from alkane to alloalkanes, alkane to alcohols, like that. You're just moving, you know. But remember, if it's saturated to saturated, it is substitution. All right. Let me apply this in a question. I want to leave you guys by 7:30. You need to rest well. All right. So let me show you how to apply this. From the same paper that we were working with, I'm just going to pick. Oh, this one did not write organic reactions. What the heck is going on with these people? All right, guys, these guys did not do organic. Maybe they didn't get there. Let me look for another paper. They didn't probably get there, but you would get there. Or you got there, rather, if I may say. Did you guys really do it, though? Were you able to cover up to that point? All right, but follow me and you would see. I'm going to be slow so that you will be able to see and do it on your own with whatever I do now. So please, I wish I could do 2 questions or 3, but if you look for some of my videos on YouTube, I did quite some questions. Let me check 2018. Let's see, February, March. I hope we have a good one here. No, there's polymers here, and we are not doing polymers. Let me look for one without a polymer. November. Okay, let's check this one. All right, this could be this is actually very good. 17 marks, guys. We're going to work together here. Please draw. If you want to enjoy organic reactions, please draw. Let's look at this together. You would see how simple this thing can be. To me, I know you're panicking there. Don't panic at all. Don't stress at all. It's going to be okay. Let me run. I want to see if I can do 2 questions. This one, and I'll look for the one with a diagram for a flow. Look at this. 3 reactions of organic compounds from the same homologous series are shown. So we have butane plus Br2 to form 2. Now, look at this quickly. What is butane? Let me make notes on this. Butane is a saturated compound. Bromobutane is haloalkane. That's another saturated. Automatically, can you tell me what reaction 1 is? Guys, okay, can we focus now? All right. Thank you, Nkem. Do you see, guys, that we're already done? What type of reaction is that? That is substitution. I want to quickly, let's deal with that one. Do you notice we are adding what? Br2. What is that? Halogenation. So once you see what's going on, we are adding halogen. You now go back to what you should know. What is the catalyst? Sunlight or UV, number 2. So if you know this now, you just say, oh, sunlight. But let's draw. Butane plus Br2 to form 2-bromobutane. Let's draw quickly. Butane. 1, 2, 3, 4. Check this. Plus Br2, that's how we do that, to form 2-bromobutane, they told us. So it means on my second carbon, there's a bromine there. Now, I want you to see what's going to happen. Because it is a substitution reaction, check, I am basically replacing the one on number 2. So what's going on? Substitution means to take and replace. So you would notice if I'm replacing or exchanging, this guy takes the place of that, and that guy takes the place of that. What do you think we are going to have at the end? HBr. Let me know if this makes sense to you. Did it make sense? So it's a matter of drawing. Once you draw and you know saturated, saturated, unsaturated, saturated, you'll be fine. You will be fine. I'm done with that reaction. They said, what is P? Straight, we're done. Look at reaction 2. Pentane plus excess oxygen. We just did that. That is combustion reaction. Pentane plus excess oxygen. We did that a while ago. Pentane is C5, H12 plus excess oxygen. We know the product. Carbon dioxide plus water. We put a 2 there. 2 times 5, 10. 2, 12. We come here, reverse it. 12, 2. 10 times 2, 20. 20 plus 12, 32. What is 32 divided by 2? 16. But check the numbers. The numbers are all even. So what do? Divide by 2. This becomes 8. Divide by 2. That becomes a 5. Divide by 2. And that becomes a 6. I think that reaction is finished. Combustion reaction, which I did with you as well. So there's nothing new. Number 3, look at what we have. Hexane. And it's giving you 2 compounds. I don't even need to read. What is hexane? Hexane is what? C6. Oh, I wrote hexase. Hexane. C6. 6 times 2, 12 plus 2, 14. And they gave you that it's broken down into 2 compounds. Oh, beautiful. We did all of this. C2, H4 plus Q. All you need to do is to count. How many carbon hydrogens do you have left? 4. And what is 14 minus 4? 10. And what is this? Cracking. Did it make sense? Look at how sweet we did all of that, like pa. But let's answer the questions. Define a homologous series. Please, you should be able to define. Name the type of reaction represented by 1, substitution. Write down the formula compound of inorganic compound P, HBr, we did. Give 2 structural formula of a positional isomer of 2-bromobutane. For those of you that were in my class, we did this. 2-bromobutane. I want what? A positional what? Isomer. For me to get a positional isomer, what am I doing? I am changing the position of that bromine. And the only place, guys, it was here. If I move it from here and move it to here, it is still 2. The only place I can move it to is to move it to the end. And that makes it 1. 1-bromobutane. And that's a positional what? Isomer. The position of the side chain. Okay, I'll redo it. The position of... Which one do you want me to do, Nati? The cracking. All right. Okay, we'll get there. Don't worry, we'll get there. Now I'm answering the questions. Use molecular formula. Write down the balanced equation for reaction 2. We see reaction 2. We answered already. C5H12 plus 8H2O. You get your marks there as well. All right. Guys, can you see that it was just a walk in a park? But I need to do one with the flow diagram. Please just bear with me. Oh, we have something similar. All right. Reaction 3 is cracking. Do you see that? They even told us now. We are supposed to define cracking. Please, I'm sure you have all your definition pages, and I defined it, but just in passing. All right? Yeah, of course she wants to do the cracking thing. Leave my child alone. All right? It says hexane. So we're given hexane to give us C2H4 plus Q. What's the formula for hexane? C6. You must know the formula. General formula is CnH2n plus 2. Otherwise, you quickly draw. 6 times 2 is 12 plus 2, 14. Okay, so what is Q going to be? We just do the maths. 6 minus 2 is 4. And 14 minus 4 is 10. Do you notice that this is an alkane? And this is an alkene. Case closed. We are done. Are we okay? Are we good, guys? Make sense? Let's try that other reaction quickly. All right, let's look at this one. This one is very important. It says study the flow diagram below. Ah, beautiful. I thank God that I'm actually looking at this. What is hydrolysis? Hydrolysis is actually a substitution reaction, okay? And you'll be seeing it. So put that note down. Hydrolysis. Oh, I do have it here. Wait, I do have it here. 1 second. Okay, I don't have it. Let's put it on this page so that we can take, if you can take a picture, then we'll be done. We'll put all our reactions. Hydrolysis. It is a substitution reaction. All right, to produce alcohols. To produce alcohol from an alkane or a haloalkane. And you would see, please just learn to draw. If you can learn to draw, you will enjoy this thing. It's quite straightforward. So hydrolysis. So here we use water, all right, for hydrolysis. Here we use water. Even for hydration, we also use water, but hydration is an addition reaction. Put a note there for yourself. Just use colors. Hydration is addition, while hydrolysis is substitution. But for both cases, we are using what? Water. And you know what an addition reaction is. You know what a substitution reaction is. Substitution will occur between what? Saturated and saturated, while addition will occur between unsaturated to saturated. Are we good, everybody? I want us to answer that question. And play around. Look, learn to play around with it. It's so nice. Check this. Where's the diagram? Lovely. 2-bromobutane. I don't know this, but I'm going to quickly see. I'm behaving like somebody who doesn't know. 2-bromobutane. Butane is 4. And I now know that, oh, bromo is sitting on carbon 2. Plus, check something. Hydrolysis. Hydrolysis. I need water. What will that reaction be? Guys, water is hydrogen and hydroxide ion. Look at what's going to happen for you to see that it is substitution. This guy will take the place of this guy. So let's do the exchange. Ta and ta. What do you think we are going to have? 1, 2, 3, 4. Do you notice this becomes what? OH, which makes it an alcohol now. But plus what? Do you remember that OH is taking the place of Br? Br is taking the place of OH. We have HBr. Does that make sense to you? Can you see we're just playing around? We are just playing around. Excess water. Write down the IUPAC name of R. That's very simple. Butane. Don't forget the AN. 2 what? All. Saturated. So the fact that they told me that it is hydrolysis already, I know this is what? A substitution what? Reaction. Oh, so if this is saturated, this would also be what? Guys, look at compound, the last one. Is the Br not on the C2? Yes, it is, Lerato. I'm counting from the left-hand side. Carbon 1, carbon 2. Lerato, thumbs down or thumbs up now. Are you okay now? So it depends on where you're counting from. All right. Guys, let's look at the last one, alkene. What can you tell me about this alkene thing? What can you tell me? Alkene, is it saturated or unsaturated? If you can just learn to draw, you will enjoy chemistry. It is unsaturated. Beautiful, guys. So what type of reaction do you think we are going to have? It's from saturated to unsaturated. What is the last letter? Good. It's an E. And the E stands for what? Elimination. It means I need to remove. Now, please, I am going to use Zytef rule here. Please watch how I'm going to remove. Since it's removing, so they said compound R react in the presence of, I want you to see something, everybody. Look at this. In the presence of what? A concentrated. Do you remember my CEDS? I told you every time I see a concentrated, what's the next thing? Elimination. Do you see that? That it's still working. Although I said we should keep it as a base, but it's important that concentrated is my emphasis. Now, we want to form an alkene. Very simple, my good learners. Check. This guy must go. Let me use a brighter color. This guy must go. We must remove because we are eliminating. All right? Check. If I now eliminate 1, 2, 3, 4, I have now removed that from there. Something is wrong with this structure. And I want you to listen to this part. I cannot remove OH alone. One hydrogen must go. The question is, which hydrogen should then go? Look at it. This is where Zytef says the pore gets poorer. If I remove this guy, I am now going to check on the next carbons, the one that are next to it. Which one has less carbon? Is it carbon 1 or carbon 3? Look at it. Which one has less carbon? The pore must get poorer. Cloney, lovely. It's carbon 3. So we got to get rid of that carbon. We're going to punish this guy for being poor. We're asking him, when his friends were getting rich, where was he? So we punish him again. Like, hey, Baba, when your friends were making money, where were you? We will punish him. Even the Bible says so. Go and read the story of the talents. Jesus took from the one who did not produce and gave it to the one who produced. He was doing crack. Oh, not me though. Okay. Because I'm rich, guys. You know what I mean? Look at my daughter. You'd see that she eats well at school. She's well taken care of. She has enough money to buy crack. All right, let's finish this, guys. So, she steals food. Banana. Okay, I'm going to have to deal with that. So, guys, check. If we remove this, what do you notice is going to happen? Do you notice what's happening there? Carbon must be bonded always by what? 4. Unati is always asking, I need to deal with Unati. Unati, why are you disgracing me? Guys, do you notice now that I have to make carbon have 4? So what do I do? Put a double bond there, and that gives me my alkene. And that is called the major product. Plus, oh, by the way, we removed water. You must always check. Did that make sense? And we're done. Junior, what did she do? Thank you, Nkem. We'll deal with all of this. But guys, did it make sense? Do you see how we manage this? Can I do one more? Because I know organic reactions can give you a challenge. Just one more for 10 minutes, and then I'll release you. Just 10 minutes. All right, Onati, leave them alone. Forgive them. They don't know what they do. You know how. You know the whole deal. Forgive them, for they know not what they do. All right, I'm choosing national papers because they are error-free. Okay, I hope this is a flow that, yes. Oh, thank God. This is what I want. This is what I want. My good learners, I'm not even going to look at the whole question. I am just going to debug this diagram. Please follow me. Follow me on this. Except I need to read. Look at this, the flow diagram. The flow diagram shows how compound A can be used to prepare other organic compounds. The number 1, 2, 3, 4 represents reactions. Please watch this. I can quickly tell you what A is. How many carbon atoms are in this story? 1, 2, 3. So it's 3 carbon atoms, right? What is this? This is unsaturated. Do you notice? The first thing I would like you to do, SSS, SUE, USA. These 3 on the right-hand side represent my reactions. So look at this. If this is unsaturated, where are we coming from? Come back here. This is the product. Oh, we can only come from what? A saturated. So compound A is saturated. Please, did that make sense to you? I'm going to, if you can get this right, I'll be done. Compound A, and it makes sense. Look at, why am I saying it makes sense? CEDS, concentrated elimination. Look at concentrated. So saturated, unsaturated, elimination. To me, I hope you see that my acronyms are now making sense. Now you are forced to go learn it. All right? Number 2, what is an alcohol? An alcohol is also what? Saturated. So what type of reaction is number 3 rather? Number 3 is a substitution what? Reaction. Let's go to number 2. Oh, hydration. Hydration means addition of water. And if you check again, unsaturated, it's only here. The product must be a saturated. Oh, case closed. So what is this? Saturated. And what type of reaction is this? It's an addition what? Reaction. And it's hydration. You must just know your catalyst. Catalyst is excess water and phosphoric what? Acid. Let's go to reaction 4. Oh, reaction 4, alcohol. What is this? Carboxylic what? Acid. If I was in class now, physical class, that child would have shouted what compound C is. And what is compound C? When an alcohol reacts with carboxylic acid, ester. Ester. Guys, did you enjoy this movement? Do you notice this? It's just beautiful. Did you enjoy the movement? SSS, SUE. The rest is to draw. And I'm quickly going to draw and we are out. Drawing very fast. What do you think compound A would be? Very simple. This is 3 carbons. And we said this should be saturated. So what should it be? It's an alkane. All right? Alkane with 3 carbons. And what would that be? Or let's read, because they could use alloalkanes. Let's read. Let's try to see. Let's read. Oh, they didn't even check. Use the information to answer. Name or homologous series. We did that. Alkanes. Write down the type of reactions. 1, 3, 4. Are you aware that we did them already? 1, elimination. 3, substitution. 4, addition. 4, esterification. Because they gave us that one as, can you see? Beautiful. All right. Consider reaction 3. Write down the 2 reactions conditions needed for reaction 3. Didn't I write it? For reaction 3. Oh, beautiful. Let's quickly deal with this. Reaction 3. What do you notice? Do you notice it is a substitution? I'm going to come back here. What is my D? Dilute, strong base, and mild what? Heat. Everything is in the acronym that I gave you. Dilute, strong. If you go back to the note I gave you, remember I told you, if a note cannot answer your queries, then it's a nonsense note. Didn't I answer it here? I did. Look at the answer. For substitution, dilute, strong base, and mild heat. And an example of a strong base, just maintain this one. Either KOH or sodium what? Hydroxide. But I want us to draw that. We just draw and we quickly end. Alkane to alcohols. Do we have a name for that alcohol? Okay. Now look at. Let me read the question so that we don't. IUPAC name of the. Do you notice they gave you a key? IUPAC name of the primary alcohol that is formed. It's an alkane. You are forming a primary alcohol. But I want us to draw as we alkane. How many carbon atoms again were we drawing? 1, 2, 3. 3. 1, 2, 3. And we want to form, please check. We want to form what? A primary alcohol. But what did I tell you to bring in? I told you to bring in dilute KOH. Or, I want us to quickly deal with this. They said it's a primary alcohol. Lovely. My hydrogen is there. Watch this. I need to get rid of this guy. Because it's substitution, I'm going to do what? I'm going to replace. Right? We would replace. So what are we going to form? We are going to form a primary what? Alcohol. There's something I want to show you. Do you notice that I'm done with my primary alcohol there? Here is what I want to quickly show you on this one. I want you to look at the difference. There's a peculiar story here. Okay, wait. I would actually prefer. I want to show you something that I would prefer something here, concentrated here. I want to show you the difference between the two. All right? I want to show you the difference between the two. That's why when you draw, you see, I'm noticing something now because I drew and I want to change something. Because I drew, so we said this guy should take the place of this guy, but I don't want to form NaH. Watch that. Don't form NaH. I am going to change this guy and put a Br so that at the end I will form NaBr. So that means my original compound is not an alkane, it's a haloalkane. But it is still saturated, so we're still fine. All right? That's why diagrams are important. Haloalkane. Seek to form NaBr. But here is, and I'm going to shut down after this one. What is the difference between the two? Please watch. I still have my compound, but I am saying for one, I'm using dilute. For the second, I'm using concentrated. For the concentrated one, I'll have to eliminate. So what will it be? I would remove this guy. Where are my rings? And I'll remove the hydrogen next to it. So what will I be forming? 1, 2, 3. I have removed these two spaces, so I'm putting a double bond. Plus, okay, please watch. These two guys are empty, so I have KOH, and I have what? HBr. Do you notice what you see there? KBr plus, here is my last emphasis for the day. Did you guys notice a difference? Please check and ask me questions here. Do you notice a difference? Busa, can you use sulfuric acid as a catalyst in hydration? You have to use dilute sulfuric acid if you want to do that. Take note of that, Busa. Very good question. You have to use dilute. If you use concentrated, you will not be having hydration. Okay, take note of that. It has to be dilute sulfuric acid. Let's add it here. For hydration, Busa says, can we use that? But it must be dilute or dilute H2SO4. If you use concentrated, you will eliminate. All right, guys, I don't know. I want to ask you here. Can you see a difference? My first difference is this. Here's my first difference. Where's my highlighter? Yeah. Dilute. When I'm using dilute, I'm substituting. But when I'm using concentrated, I am removing. So you would notice saturated. But apart from that, look at, we have two other products. Here I have one. Just draw. Yes, Entle? Say, how come in the, yes, Entle, that's where I'm going. How come there is no water? That's the observation. Entle, are you aware that when you say substitute, you are taking this one and replacing this one to replace that. That's all. Entle, did it make sense? Exchange. But for this one, I am removing these guys completely, taking them out. That's why we now have water at the end. That is where I want you to see the difference that I wanted to see. Good question and good observation. So where did it go? It here. Those are the two. It didn't go anywhere, Entle. HBr and KOH. So that's why I wrote it here. This is acid and that's a base. It will form salt and water. So your HBr, KOH, you form water here, and then you have KBr. Do you see where it went now? Let me know quickly, Entle, do you see where it went? Awesome. So guys, that is the major thing, but it's easier when you draw. If you draw, you can figure out, okay, I'm going for saturated, so I must have a saturated compound. No other thing must be added. Here, I'm going for unsaturated. Account for everything that you see. So please you would see that this reaction, this and this are actually the same, but the difference is the dilute and the concentrated. I hope that makes sense. Let's see, reaction 4. What is reaction 4? Reaction 4 is an ester. Everyone should be fine. I want something on reaction 2. They didn't ask us for reaction 2. What is reaction 2? Hydration. Oh Let's do that. Let's do reaction. I promise you that's the last one because I want to teach you Markovnikovs. Reaction 2. What do we have? An alkene. All right. So reaction 2 looks like this. 1, 2, 3. And because now it is hydration, we are adding what? Water. Remember, what is this? Unsaturated. What are we expected to have? A saturated compound. But here is, please, I want you to get this one as we round up. I told you that H2O can be broken down into H+. My question is this. Where will where will hydrogen be added? And that will be my final statement. Where will hydrogen be added? The rich gets richer. Guys, this one came with their own hydrogens. All right? These ones are fine. These ones are fine. It is these two that we need to sort out, these two bonds. And these two bonds, these two guys must come in and sit, but they will check. Which one has more hydrogen? Is it carbon 1 or carbon 2? Oh, Busa gave me an answer already. Oh, Kim also gave me an answer. The carbon with the most what? Hydrogen. So, and that is Markovnikov's rule. The rich gets richer. Good night, everybody. That's what I would like to share with you. Your answers lie on this page. To me, do you see? You need to swat this page. That page answers all your question on organic reactions. I hope it made sense. I hope we're able to help. Yes, Unati, tell her. We must support the family business. How? Good night, everybody. It was so much fun having you all. All right, Junior, I'll try to stay with no crack tonight. No crack tonight. Ntanami, no crack tonight. Where is Priscilla? Adeye. You're welcome, Mali. Oh, Kevin is a part of the family. Just good night, guys. You guys are. Don't worry. I need to see Priscilla. I need to see. Somebody should send me a picture of Priscilla so that when I see her, I can attack her, since she doesn't want to let us know who she is. There's one Uju. Osa, guys, there's so many of my blood in your class. There's Uju as well. I need to have a family meeting. Yeah, she fell asleep. Oh, she's washing dishes. Good night, guys. Good night. Good night. Good night. Good night. Good night. So how is Unati, my child? Entle, don't worry. It's a discussion for another day. Ask her tomorrow. She'll tell you. She'll tell you. Bye-bye.